Good morning, everybody. Thank you for coming. Senator Hutchinson and I wanted, along with Senator Bozeman, who is our ranking member of the subcommittee. John, come on over here closer. The three of us wanted to have this hearing today so that the American people know what's going on in space, that there is this extraordinary contraption that is about 240 miles above the Earth, that is as large as from the end of one end zone of a football field to the other. That's 120 yards, and as wide as a football field. And if you will just look at the NASA model there, you will see that that is certainly true. If you look at all the components there, you will see that part of it is Russian, of which the Soyuz docks there, which is the vehicle that comes and goes, and most recently, since the space shuttle was shut down a year ago, is the vehicle that we have delivering crew until we have the American rockets that are man-rated with all the redundancies and escape systems that are being developed as we speak. But in addition, we have a number of different payloads that are delivering cargo, the most recent of which, American, was the successful flight and successful delivery of cargo by one of the commercial ventures, SpaceX. And as we speak, we have already rendezvoused a Japanese space module that is delivering cargo, and it will be docking within a matter of days. There is also a crew on a Soyuz that has launched, and have they docked yet? Oh, it's the Progress module, which is a Russian module. It is in the vicinity of the space station, and they're working out the sequencing for the delivery of cargo from the Japanese module as well as the Russian Progress module. So there are a number of these payloads that are going up. In the case of SpaceX, it also had the delivery coming down of experiments that were loaded onto the spacecraft that returned successfully to Earth. Now, I want to toot the horn of Senator Hutchinson, but I want her to hear me tooting her horn. Senator Hutchinson is responsible for the American laboratory module to be designated a national laboratory. Our national labs are some of the great assets of this country. Los Alamos is just one, for example. The International Space Station, the American module, is designated a national laboratory. And part of what the three of us wanted today to do is to have this testimony from the people who best can tell us, including our American astronaut who just returned, and who has spent in the course of 3 space flights over 1 year in orbit. And Dr. Pettit is going to share with us a number of these experiments and real-life things that are beginning to happen, such as the vaccines that we have already mentioned in the last hearing that we had on the progress of the overall space program. So with that, I have other comments that I'll make later on. Senator Hutchinson, let me turn to you, and then to Senator Bozeman.
Okay. I just wanted to open today's hearing because we have lost a space pioneer. And Sally Ride did so much to promote space, and even though she tried to get out of the spotlight, she just attracted so much attention because she was interesting, she was committed to physics and science, and she was committed to getting girls to start taking the STEM courses. And when I wrote a book in 2004, I did chapters on the women pioneers in different fields. So I did education, politics, government, sports, and aviation. And then I interviewed women who were still breaking barriers in the same field. So my aviation chapter was Amelia Earhart and Jackie Cochran. And my interview was Sally Ride. What could be more perfect than the first women to actually fly the long distances and prove that women could be great pilots, but then the first woman in space. And in my interview, I asked different questions about what was the most important trait for her success, and she said it's the ability to work with other people, which she found very helpful as the first woman astronaut. And I said, oh gosh, that's interesting. I would have thought you said perseverance. And she said, well, that's a close second. And then I asked her what was her most helpful childhood memory. And she said, you know, it's funny. It was actually an issue in school. And I got discouraged by something. I don't remember what, but I came home and I was very down. And my father basically said, well, you've just got to reach for the stars. She said, that's ridiculous to think about right now. And she said, but it did happen. So I think we all owe her a great debt of gratitude, and I just wanted to start this hearing by recognizing how much she gave. I want to thank both the chairman and the ranking member of the subcommittee for being here, because Senator Nelson and I have done so much to keep the emphasis and the importance of NASA in the forefront. I'm a budget cutter. I'm a person that wants to set the top line of a budget, but then it's so important that we set the priorities for what goes in that budget. And Senator Nelson and I and many others have tried to assure that we don't eat our seed corn, that we continue research, that we continue to reach for the stars, to go beyond where we are now. And NASA is the agency that can do that. And there have been people who've tried to abolish NASA, frankly. And I think that going forward, I will be certainly very comfortable with the ranking member, John Bozeman, who has done a great job of learning the issues and where we are, and he's hit the ground running. And I'm so appreciative for Senator Bozeman and his interest. Let me say that establishing our part of the space station as an American national laboratory was a great accomplishment in that it opened the space station for research from outside entities. And it can be private companies, it can be universities, it can be open to anyone who is going to do research that can only be done in space. And we all know that you can only do certain experiments in space because of the microgravity conditions, and you can't duplicate that on Earth. So finding out what is out there is so important for our future. And we've seen what exploring space has done for us in national security, being able to put satellites up there and do satellite surveillance, satellite-guided missiles, has helped our national security so much. But now we have this laboratory, and one of the issues of this hearing is going to be what we're doing there, and certainly are we going to extend it further than 2020, or is 2020 its life, and what are we going to do to fully utilize it? I was at Johnson Space Center a few months ago, and I saw the hits on the alpha magnetic spectrometer. One of the almost casualties of the budget cutting without establishing priorities was that we were told that there wouldn't be room for the alpha spectrometer, the alpha magnetic spectrometer, to be taken into space by a former NASA administrator. And many of us fought back, and Dr. Sam Ting fought back, the Nobel laureate at MIT, who felt that we had to have that up there to get the cosmic rays and try to determine if there is dark matter and what it is and what effect it will have on the expansion of the universe. And I'm sitting in the Johnson Space Center looking at the hits on the alpha magnetic spectrometer, and it is so far 18 billion hits of cosmic rays, more than even Sam Ting thought we would get in this time span. And so this is a very basic science that we're doing there that could lead to any number of things in the determination of what the universe is, and also if there is dark energy, is it something that can be harnessed? No telling. He doesn't even know everything. And as Dr. Ting so aptly points out, almost all of the major research that we have done since we went to NASA and set NASA up, everything that we went into to research was for a purpose that is not what we got, but what we got was even more important. And that's why continuing the priority of NASA and space exploration is so important for our European partners, for our own quality of life and capabilities to expand. So, Mr. Chairman, thank you very much for holding this hearing. I did request this hearing because I want to know what we're doing up there. And so I'm looking forward to hearing from all of you from your different perspectives. But I do hope that as I am going out the exit door, that we are able to excite the American people as we have in the past on what the future is. And I thank you all for being here.
Senator Bozeman.
Thank you. Thank you very much, Mr. Chairman. I have a very eloquent statement that I'd like to put in the record in the interest of time, with your permission. But I appreciate Senator Hutchison mentioning Sally Ride. I've got 3 daughters that are all grown now and have done well and very independent. But looking back, it's individuals like this, that the example that you truly can do anything that you want, as a female now, that has certainly not been the case, for always. And so, again, we so appreciate her example in so many different ways. I want to thank you two, Senator Nelson, Senator Hutchison, for really, championing this for so many years. Senator Hutchison mentioned the ability to get along, as something that was so important, and certainly you two have modeled that in working together so closely, creating a very bipartisan group, not only here, but also, and it's difficult working with our House colleagues, such that, that we have this bipartisan, bicameral situation, which truly is unique. There's not very many situations like this, so I do appreciate your all's leadership so very much. I'm going to be running in and out. I've got a markup in EPW, and so in a little bit I've got to sneak out in just a second. In fact, Senator Boxer and Senator Inhofe will grab me by the throat if I don't get over there in a minute. It's a unique committee. We're going to be voting on the Great Apes Act, and then you have also the Safe Chemicals Act. So there's a little something for everybody over there. But we do appreciate you all being here, and we certainly appreciate your efforts. Thank you.
Sally Ride flew twice. She flew in '83 and '84, and I'll never forget that launch the first time. She being the first American woman in space, there was a chorus that went up, "Ride, Sally, ride." And I think she captured the spirit of America in her participation in the space program. She was a PhD in electrical engineering, and after she left NASA, she never stopped working in order to inspire the next generation of explorers. Now, since the subject today is the space station, this thing started when a Navy SEAL, Bill Shepard, opened the hatch on November the 2nd, 2000. And he floated from a cramped capsule into the space station. And thus he began as the commander of Expedition 1, and the International Space Station has been continuously occupied ever since. The act that Kay Bailey was mentioning a while ago extended the ISS operations until 2020. It authorized that. But once you hear about what's going on today on the space station, I think it is very short-sighted to think that this thing is going to be cut off in 2020, but that the research will continue on this extraordinary facility, of which it has a pressurized volume as large as a Boeing 747. That's how big it is internally. And then, once we are at the end of the design life of it in low Earth orbit, some 240 miles up, circling the globe every hour and a half, what's the likely future for it? Perhaps to boost it further, maybe to the Lagrangian point between the Earth and the Moon, which is the point that the Earth's gravity stops and the Moon's gravity starts, or possibly that Lagrangian point on the other side of the Moon. And maybe as a future base, parts of it, not necessarily the whole thing, but maybe parts of it could be used in that situation then as a way station if we decide in our future exploration that we want to go to and from the Moon's surface again. These are the possibilities. And so today we are very fortunate to have a very distinguished panel of witnesses to talk about the accomplishments. Bill Gerstenmaier is NASA's Associate Administrator for Human Exploration and Operations. We look forward to continuing the discussion that we started last month about the commercial space operations to and from the space station and the scientific discoveries that we talked about last time. We also have Thomas Reiter. He's from the European Space Agency, one of our partners. This is the International Space Station. And he is one of 2 space station astronauts with us today on this panel. He spent over 5 months on the ISS, and he is the European Space Agency's Director of Human Spaceflight and Operations. And he's going to share ESA's perspective on operations and research aboard the ISS. From the Center for Advancement of Science in Space, we have James Royston, and he serves as the Interim Executive Director. CASIS is a nonprofit organization working with NASA to manage a significant portion of the ISS research. And he will touch on how CASIS will help us get the most out of our nation's investment in the space station. And then we have Dr. Donald Pettit, who just returned on July the 1st. This last time he was on the station was 193 days. He's flown in space 3 times, as I mentioned earlier, and he has lived aboard the station twice. His creativity and his technical wizardry make him an outstanding example of what the human element brings to research and discovery. So I'm going to take the privilege of the chair, and I've already consulted with Senator Hutchinson. Dr. Pettit, we're going to start with you. We'd like to hear from you. Welcome home.
Thank you, Senator. It's an honor to be here and to be able to tell stories of what it's like to be in space. There are 7 billion people that live on this planet. There's 6 people currently that can call space their home. And it is an incredible privilege to be part of the 6 people that are currently living off of this planet. And with that privilege comes a responsibility when you return to tell stories about what it means to explore. And this is pretty much universal to any explorer that comes back in whatever period of exploration that they belong to. They tell stories, they talk about the meaning of the exploration, they talk about why we explore, and they incite ideas and thoughts in people who don't have the opportunity to go off and do that exploration themselves. And this hinges on frontiers. Space is very much a frontier. We have frontiers all around Earth. It could be under the stage of a microscope. It could be through the eyepiece of a telescope. Bottom of the ocean, in the Arctic and Antarctic regions, there are frontiers that surround us. Space happens to be one of many frontiers we can explore. It happens to be the frontier where I am spending my career exploring. And in this frontier, your earth-honed intuition does not apply. Things don't work the way that you think they should. The answers are not in the back of the book. And this makes a place that's rich in discovery. And I think that's one reason why we go to these frontiers. And when we go to these frontiers, we can see things that you never imagined, because nature has an imagination that is greater than what human beings have. And the only way we will know what is there is by virtue of going and seeing for ourselves what happens to be in this frontier. And from that, it can enrich our minds and tickle our imaginations. And initially, these observations enrich your society. And eventually, you will make technology and other discoveries, other advances that will enhance the standard of living and enhance the arts, enhance theater, film, literature. It will embed itself into your society. And I think you can conclude that exploration in these frontiers is a metric for how viable your particular country happens to be. I'm happy to be here and answer any questions that you have. Thank you.
We will get into that. Mr. Gerstenmaier.
Thank you very much. The title for this hearing, the International Space Station, a platform for research, collaboration, and discovery, I believe is extremely fitting. Through the discussion today, I hope we will all gain a deeper understanding of the amazing facility in space that we have created. I also hope we gain, through concrete examples, an understanding of what is happening every day on board the International Space Station. We're not simply talking about enabling research. We are really doing research every day on board the space station. The station is an amazing international research facility. The ISS major assembly is complete, and we're beginning to see significant research activity. Research was done during the assembly phase, but now we're focusing on the research itself. Today, the focus on research, and we're trying to find ways to make it easier for the researchers to get their experiments to ISS. We're also trying to get the word out about the research facilities that are in place on board the space station. You know, there are fluid experiment racks, combustion racks, glove boxes, Earth observation facilities, material processing facilities, a vacuum interface, ample power and data interfaces, to name a few of the major facilities that are on board the space station. There's also a crew available to perform the research and interact with the experiments. This is a tremendous research capability, and it's present in the high vacuum and low gravity environment of low Earth orbit. A facility like this has never existed for use by researchers throughout time or throughout the world. ISS can enable technology development, understanding of the human system performance in microgravity, and enable both fundamental and applied research. ISS also offers a unique capability for commercial companies to test the advantages of microgravity research to their industry. Commercial companies can experiment at very low cost to determine if there's a competitive advantage for them over other companies that do not take advantage of space-based research. ISS could enable development of a new economy based on space-based research. Today, we're seeing a real increase in the research on ISS. As I discussed earlier, there are combustion experiments aimed at understanding the fundamentals of combustion. This may allow better and more efficient combustor designs. The alpha magnetic spectrometer that was discussed earlier is looking for dark matter, and that may ultimately help us understand the very beginnings of the universe. There are fluids experiments. And as we sit here today, and you mentioned the HTV, the Japanese cargo vehicle, is approaching the space station for a docking on Friday with a large number of research experiments. The Japanese cargo vehicle is carrying a system to deploy microsatellites from the space station. It's carrying a remote Earth observation camera system to monitor disaster areas on the Earth. It's carrying an aquatic habitat that will monitor the development of fish in microgravity. It's carrying a next generation of software-defined radios where the radio can support multiple frequencies by just simply changing the software inside the radio. And lastly, it's carrying two Lenovo YouTube Space Lab student science experiments to the space station. These students came to Washington with their experiments were selected to fly on the ISS by a team of judges that included Stephen Hawking. They did this activity through the internet. They participated with many folks here, and the exciting thing was they got to meet with Sunita Williams, who is presently on board the space station. So Sunita, who they actually interfaced with and talked to, will now be performing their experiments on board Space Station this fall. So it's amazing that these students were here in Washington in the spring. Their experiments are flying the station here this summer, and their experiments will be performed on Space Station in the fall. This is direct evidence that the Space Station team can provide research opportunities in a very timely manner for folks out in the research community. Again, this is an amazing time for space-based research. ISS is showing that it's an amazing research facility. ISS can inspire students and engineers to think differently, as Don talked about, and we will continue to make it easier for research to get to ISS and be performed there. We are showing that ISS is an amazing research capability for this nation and the world. We cannot predict what results will come from the ISS and long-duration space-based research, but we can and we are making this facility available to a talented research community. True advances come from discovery, and ISS is a platform for discovery. I look forward to your questions.
Thank you, Mr. Gerstenmaier. Mr. Ryder?
Dear Mr. Chairman, dear members of the committee. Oops.
Don't worry about those bells.
Okay.
That's what's going on over on the floor of the Senate.
It's also a great opportunity and honor for me to testify before you today and present the European Space Agency's role and capabilities on ISS. The successful utilization of ISS is of highest priority for the European Space Agency and for the European ISS partners. ISS is a unique platform for scientific research and technology development. It is in full recognition of the extraordinary utilization opportunities of the ISS that Europe decided to engage as a full and very active partner in this unparalleled international cooperation together with the United States, with Russia, with Japan and Canada. Europe, working through the European Space Agency, developed and operates two key elements. The Columbus Laboratory, which you see here in the front side on the left, and the automated transfer vehicle. Columbus is a multifunction laboratory which shared with NASA and the other partners, and it is equipped with 10 interchangeable payload racks containing an advanced number of research instruments. The second key element, the ATV, automated transfer vehicle, which is able to deliver more than 7 metric tons of cargo to the ISS. One of these vehicles is currently docked to the International Space Station till mid of September, and 2 more of these vehicles are about to come next year and in 2014. Apart from cargo delivery, ATV is providing fuel for maintaining attitude control and giving boost to the station, and also gas, water, and other supply articles. Now, apart from Columbus and the ATV, Europe has also contributed to other elements, equipments, and design skills. For example, the DMSR, the data management system, which has been a key part in the station's brain, so to say. 2 or 3 nodes that link station components, a dome-like structure with panoramic windows called the cupola, allowing astronauts to operate the station, robotic manipulator system and other equipment, and inside US Destiny research module, various laboratory equipment like the material science rack and freezer units. Europe also provides members of the ISS crew. Since 2001, 18 European astronauts have lived and worked on board ISS, and one of my colleagues from Europe, Dutch astronaut André Kuipers, just returned a few days ago together with Don Pettit from a half-year work on board the station. Europe's participation in the ISS program means that throughout ESA's member states, thousands of Europe's scientists and engineers at hundreds of universities and high technology companies are working on the frontier of 21st century science and engineering. ESA has implemented a broad portfolio of research activities covering fundamental science, applied research, as well as human exploration, preparation, and technology development. To date, ESA has performed more than 200 experiments on board ISS, and since the deployment of the Columbus Laboratory in February 2008, increasingly long-duration experiments at an average of 30 to 40 experiments per year have been implemented. Examples have already been given in the area of human physiology, fundamental physics. Let me just give one additional example from the area of material sciences, which we have just concluded a project investigating processes for the development of new lightweight alloys. And these new lightweight alloys are now used for turbine blades in aircraft engine and in an industry valued some 2 billion euros over the next coming years. Many of the fundamental and applied research projects conducted within the European Programme for Life and Physical Sciences, called ELIPS, are creating a growing knowledge basis to improve production processes and to create new products such as medical equipment, casting technologies, and other miniaturized sensors and devices. Of course, the ISS also offers outstanding opportunities as a testbed for human exploration preparation beyond low Earth orbit. Apart from already ongoing or planned scientific and technological investigations, ESA supports challenging new ideas to pave the way for human exploration beyond low Earth orbit. The joint implementation of these activities by the whole ISS partnership will allow rapid progress for the preparation of future human exploration missions. The European Programme for Life and Physical Sciences in Space involves some 1,500 scientists in almost 150 projects included in the research pool of ISS experiments. Now, besides the significance of the ISS for science applications and technology, its utilization opportunities and the astronauts working on the station are strong inspiration for the young generation to consider science, technology, engineering, and mathematics education. In this context, ESA carries out education activities on the ISS in close collaboration with our partners. The continuous efforts of the ISS partners for the global promotion of the ISS accomplishments with dedicated publications of the ISS Program Science Forum and public events like the recent ISS Symposium, which took place in Berlin, highlight the value of the International Space Station and the strength of its international partnership in the public. Now, in conclusion, the successful and optimal utilization of the ISS is important to the European Space Agency in order to demonstrate to its member states the return of investment. ESA has already reaped the considerable benefits from the scientific research, applications, technology demonstration, and education activities performed on the International Space Station, and more are expected to be realized in the continuation of ISS utilization in the years to come. I would therefore like to underline an extremely important dimension of this international partnership in the ISS program, the excellent and highly valued cooperation between ESA and NASA. Forging such an international partnership and working together as partners is often referred to as one of the biggest achievements of the ISS program. It is the international partnership that brought the ISS and its unique utilization opportunities into existence, and we will also need an international partnership, probably even a wider one than the one for ISS, when aiming at the next steps for human exploration. Sorry for extending a little bit the 5 minutes. Thank you very much, and I'm ready to answer your question.
This is the first time that we've had a representative of the European Space Agency in a decade testify in front of this committee. So, Mr. Reiter, we appreciate that very much. How many days were you in space?
In total, 350. I flew to the Russian space station near 95 for 179 days, and to ISS was 171 days, so 350.
Very good. Mr. Royston, tell us about cases at the Kennedy Space Center, how you're preparing the experiments to go to the station.
All right. First, I'd like to thank the committee for the opportunity to speak here today. It's a real honor to sit here in this panel and in this room with those that envisioned, built, and recently spent time on the International Space Station. To our elected officials, I want to thank you for your leadership, support, and ongoing commitment to this great national asset. Especially like to thank Senator Hutchison for your outstanding service and commitment, not only to the ISS, but also to manned spaceflight. Your leadership and dedication is why we're here today, and you will definitely be missed. I'd also like to thank Senator Nelson from my home state of Florida for all your past, present, and future leadership in space. And I must acknowledge the junior senator, also from my great state of Florida, Senator Rubio. As you are aware, CASIS was formed in response to the direction provided by this committee regarding the independent management of the National Lab. The CASIS mission has one overarching goal, and that is to maximize the use of the National Lab. And by doing so, we need to give our taxpayers the return on investment they deserve. This is a challenging task. To achieve this goal, CASIS must stimulate and open new markets and introduce new users to this unparalleled asset. We must help all Americans understand why we go there and how it benefits them. And we must fully utilize what I believe is the best teaching tool ever created to inspire our next generation of scientists, mathematicians, and engineers. In our short existence, CASIS has made great strides in spreading the word about the potential of the National Lab while building a solid foundation that will guarantee the future success of this organization. In line with the original vision in our proposal, our staff has worked urgently to partner with industry, academia, and others to ensure that CASIS can be responsive to the needs of potential users and to maximize utilization. Our world-class panel of scientists have identified initial avenues of promising research after poring over more than 135 projects flown in space to date. We have conducted extensive outreach activities, meeting with over 160 companies and organizations from coast to coast to convince them of the benefits of doing research and developing products in space. This ongoing effort also provides us with valuable information on how industry views space and the barriers to doing business on the National Lab. We have issued our first funded solicitation for research, with many more to follow. We have taken steps to enhance the capabilities of the National Lab, from an external research platform to new software enhancements. We have assembled an expanding list of hardware and integration experts to assist researchers in getting their projects to space. We have worked with NASA to increase the efficiencies and speed by which we can get projects from just an idea onto orbit. We have become an enabler of the new commercial spaceflight industry, and we will build their backlog that will drive the flight rates. We have enticed new players from non-traditional markets to develop their consumer goods on the National Lab. We have attracted more than 30 unsolicited project proposals, which are currently going through our evaluation process. We are working with Fortune 100 companies and brand new startups that see space as truly a new emerging market. We have created product endorsements capable of bringing the awareness and the wonder of the ISS into people's living rooms. And we have established an education program that soon will be capable of reaching hundreds of thousands of school children in a very short period of time. And most importantly, we have met our key milestones that were laid out for us in our performance plan. And as we transition from our stand-up phase to our operational phase, I'm excited to tell you that the permanent board of directors that includes some of America's brightest minds from business and science will soon be announced. I firmly believe that this board, along with our new executive director, will exceed the expectations envisioned by this committee and also by others. In closing, I believe this is our defining moment. The outpost is in place, the railroads have been built. History will look back at this moment as a time when industry and government came together as true pioneers. Companies invested their own money to ferry cargo and humans back and forth from this great outpost. It is our moment, and working together, we can open this new frontier to all Americans for the benefit of all humankind. Thank you, and I look forward to your questions.
Thank you so much. I'm going to turn first to Senator Hutchinson, and I would like, in the course of the discussion, if you all would bring out what is going on the development of the vaccines, an up-to-date report. Senator Hutchinson.
First of all, Mr. Royston, thank you for the report, because we are anxiously awaiting the appointment of the board so that we can see the cases get up and go and really start showing results, and I think the board membership will be crucial, and I'm encouraged that you're saying it will be leading scientists as well as people in business. Dr. Pettit, I'd like to ask you if you identified any areas, and of course, Mr. Ryder, I'd like for you to jump in as well on this, areas where the ability to perform valuable research aboard the space station could be improved. Are there any specific suggestions on what we could add or what more would be effective on the space station for the basic research?
Senator, currently, I believe the rate-limiting resource for doing scientific research on space station is the availability of crew time. We have an amazing infrastructure that's currently just getting going with the commercialization of space for bringing supplies to space station, where we have more scientific apparatus on space station, more equipment waiting to be used, more science experiments in the queue than we have crew time in the USOS segment with 3 crew members that we can spend working on this. And currently, crew members are working about 13 to 14 hours a day. And out of that, we can get about 6.5 hours of mission programmatic work done. And you may wonder why we work 13, 14 hours a day, we only get 6.5 hours of program work done. That's because we're in a frontier, a harsh frontier, and we spend 13, 14 hours a day just to keep the machinery going and keep it possible for human beings to be there. And you will find this is commensurate with other frontiers that are harsh on the surface of Earth. If you go to Antarctica, which I had the opportunity to go and participate in the Antarctic search for meteorite expeditions that's jointly funded by National Science Foundation and NASA, we were looking for meteorites on the glaciers, maybe 200 miles from the South Pole, living in Scott tents, which have changed very little from the design that Scott used when he did his expeditions. We would spend 13 to 14 hours a day working in this Antarctic environment to enable about 6 hours of actually mission work gathering meteorites. And we would spend time working on our snowmobiles. We would spend time just trying to chip at the ice so we could make water, drying your gear, all these shoveling snow so your tents wouldn't get buried by the sastrugi. And we would work 13, 14 hours a day just to enable the 6 hours of on-the-mission work. And I think if you look at deep sea, people living in the deep sea doing work, saturated conditions on platforms, it is difficult to put human beings in a harsh environment and have them work more than about 6 hours of on-the-mission work. And so what we find in space station is commensurate with what we find on Earth in these harsh environments. And you reach a limit with a crew of 3 of how many hours can you work and still keep your mind, still keep your wits, and still get enough sleep so that you can respond to contingency situations. And so currently, our ability to do the engineering and the organization to get scientific equipment up and the ideas behind the science experiments, there's no shortage of that. It's crew time.
So we need to get 7 people in that station. That's good. Mr. Ryder, did you have anything to add?
Yes, thank you, Senator Hutchinson. I believe, considering the fact that we have almost just transitioned from a build-up phase of the ISS to a quasi-steady state operation, it's a little bit early maybe to really say if we already are utilizing the station in an optimum way. Donna has just mentioned we have given parameters, assets, crew time is one of them, up and download, the scientific facilities that have been mentioned. And I think the next years will show where there are further areas of improvement. Now, from a programmatic point of view, I can imagine that, for example, in the coordination, in the international coordination of research subjects, there is space for optimizing the processes. And in fact, ESA has currently identified more than 20 joint experiments together with NASA, and in total more than 50 with all the ISS other partners. And the shared use of these unique orbit research infrastructure and the assets is of high importance and will help us to see where there is area for optimization. In addition, I have to say, of course, looking at the internal processes, there are certainly areas where I will look into the future. For example, one of the remarks I'm receiving from the scientific community in Europe is that the turnaround time maybe can be improved. This is motivated by comparing it to the time of the Space Lab, which was flying a couple of years ago on board the shuttle. And I will look into the possibility if we can indeed increase the time from the moment where the scientists are proposing their experiment until they hold the results in their hands. Also, I think in a structural way, we are using multi-user facilities, big facilities in the various modules. And I will see if this is the right balance with these huge multi-user facilities compared to small experimental hardware which is dedicated to single experiments, if we can optimize that in order to improve or to increase the scientific outcome, but that will need some time of this steady state operation that we have just entered.
Thank you very much. I'll have another round, but let's let everybody
Okay.
go. And I like your virus issue.
Yes.
We need to cover that.
As a matter of fact, I want to ask you about that, but I just want to point out that since we were talking about Sally Ride, that the American astronaut on the station now, Sunita Williams, will become the second female commander of the space station crew coming this September. The first female space station commander was Peggy Whitson, who is presently the chief head of the astronaut office. And so again, we see these women pioneering. I thought it was also in the number of comments that had been made to the press about Sally that one of the most interesting was from the first female commander of the space shuttle, Eileen Collins. And so with that backdrop, we proceed. Would you all, before I turn to Senator Rubio, would you all share with us, whoever, about the advances on the vaccines?
Yeah, I can do that a little bit. Where we are is, you know, we've learned that almost all bacteria and viruses in space mutate into a large differentiating strain. And we've flown salmonella several times on the shuttle.
I couldn't quite understand. Did you say large and different strains?
Yeah, different, and they mutate to various strengths of the various vaccines or various bacteria and viruses. So, for example, salmonella, you fly it up and you get back a whole variety of different salmonella than you would typically see here on the ground. Some are stronger, some are weaker. Then what we've been able to do, or what the investigators have been able to do, is they return these samples to the ground. They then learn which genes turn on the strength of the salmonella, which genes potentially turn it off. Then they can genetically engineer a strain of salmonella that's strong enough to give the human an immune reaction, but not strong enough to actually give you the disease, and that's the basis of the vaccine. So they've done enough trials on orbit that this looks very promising. And the same thing can occur for viruses. So flus, you could potentially engineer a flu vaccine ahead of time with a very quick turnaround. Again, it's still conceptual, and we don't understand why bacteria and viruses perform this way in space. The company is close to taking this into FDA trials. We've done almost enough work to go complete that activity and take it into trials. I believe they would still like to fly a few more samples to space to to get some more material back and then maybe do a little more research before they prepare the final package that goes to FDA. We're still discussing with them exactly how they're going to work that out in the future. But this is one very promising area where we don't know exactly the reason that this occurs in space, but if you give it to a creative industry, they're able to take this phenomena and then apply it in a way that's tremendously beneficial to us here on the Earth. So I think this area of research in virus and vaccines has a lot of interest to us. Arizona State is also looking very hard at trying to understand why this occurs. So they're looking at it from kind of the pure research side. What is unique about the properties of microgravity that causes these viruses and bacteria to behave in this unique way?
That's going to be
very
essential.
promising.
So because you can't manufacture enough up there to bring back very easily. So that's really going to make a difference if they can figure out what that causes.
And the advantage is once you understand which genes are turned on and turned off, then you can manufacture this vaccine on the Earth. So it no longer requires you to go to space. So you just use space to essentially spark your creativity about which genes are effective in making the virus stronger or weaker. And then that can be used on the ground then to actually generate the vaccine.
What about the vaccine for the raging bacteria, MRSA?
It does the same exact phenomena as the others, and we believe a similar strategy can be developed for the MRSA, the resistant bacteria that's a tremendous problem to us in hospitals. So again, we're working with some companies to go take a look at that as well.
Could I just pursue this for 1 second and ask you, if you've got vaccines and can it also apply to cancers? And can you grow cancer cells and look at a mutation and determine if there's a vaccine or an antidote for that?
It's not as clear in the cancer case, but we have some research that have proposed some investigations along the cancer line. But what we have done is we've flown a variety of both bacteria and viruses to space to confirm that it's there. But we have not done enough research in the cancer area to understand if there's a connection in there. And we could get some of the actual researchers to come give you some information specifically.
Yeah, because I know they've done breast cancer cell growth in space, and if they could do the same for that would be a medical breakthrough of phenomenal proportions. Well, thank you.
Mr. Royston, what is CASIS doing to manage this kind of research?
Good question, Senator. I think with this, and Mr. Gerstenmaier did a good job of explaining what some of the areas that are being looked at and what's been done. One of the things that I see CASIS is really providing a real baseline to is with our, as you will see soon, the board that's coming on, let alone our scientific collegia that's made up of some of the brightest minds out there in biotechnology, materials technology, but especially in the bio areas, that we can take and baseline all this work. Because as a nonprofit, we're not trying to get new research money, or we're not trying to be, somewhat biased within our research. We need to be able to gather that, put it together, and that's what we've started doing, so that we can then pass that on to researchers that are looking at areas of either antigenicity, muscle wasting, osteoporosis. But we will have gathered that up and put real fact around the science and be able to say this is the baseline by which you can build on.
And Senator Rubio, before I turn to you, this prompts another question I've got to ask the two of you that have been in space for so long. What we're finding in the annual physical exams is bone loss. What's been your experience with this, since I would assume that the bone loss would be directly proportional to the amount of days in space?
Senator, bone loss is something that we're starting to get a handle on, and we have an empirical remedy. I won't call it a solution, an empirical remedy that if you exercise in the right way, and in some respects, a 6-month trip to space station is like spending 6 months in health camp in terms of the amount of exercise that we do, we found that this keeps the bone density at bay. It doesn't prevent it, but it keeps it in a manageable category. And again, we don't know why. It's an empirical remedy. We're working on what the fundamental cause of this is. And I liken this state to where scurvy was around 1750, when some British surgeon found out if you suck on citrus, you keep scurvy at bay. They didn't know why. It took another 150 years before we even discovered vitamins and the idea that small amounts of organic compounds are essential in maintaining human health, and then the fundamental cause of scurvy through lack of vitamin C. And it's the combination of, first, an empirical solution which allows the seaman to go out and not get this disease, and eventually coupled with the basic understanding, and it's the basic understanding that allows all the people to stay on the continent that don't go on these voyages to benefit from this information, which is literally pried from the souls of those who explore. And this is what we're doing right now with the bone density loss. We don't know why. We need to continue the effort so that we understand fundamentally what's going on, because we've got this gravity knob which we can now tweak and experiment on human beings as well as other creatures. And this allows us to dissect out new pearls from the human physiology. And we've got this empirical solution that will allow us to continue to explore space. But we need to understand the fundamentals, and that's what will bring the benefit to everybody that stay firmly planted on this planet.
Of course, osteoporosis is a real problem here on the face of the earth. Senator Rubio.
Thank you. It's actually along the lines of what you have already been asking, so I'll just continue it. You know, one of the things that we face this challenge with today when you talk to the everyday man or woman on the street is, well, why are we spending all this money at this time in our history on these things when we have so many other needs? And I think one of the answers to the question is what you've been talking about today, is all these innovations that are only possible in that setting. So we've talked about vaccines, you talked about bone loss and what other kinds of, I think this is for the whole panel, what other kinds of such, advances, whether it's for commercial and consumer application or health application, what other kinds of exciting things are happening up there in that setting that justify these expenditures, which allows us to get people excited about space travel internationally, but also domestically?
I'll punch the button on the microphone again. If you look at fire and its either discovery or learning how to tame fire is what literally brought us out of the cave and allows us to have our civilization in terms of what we know now. Fire gives us our electricity. Fire allows us to have vehicles, airplanes, and cars and machines. It literally turns the wheels of our civilization. Fire has, and from a scientific point of view, we don't call it fire, we call it combustion. It has a strong gravitational factor to looking at what's going on in combustion. And we learn empirically that heat rises, right? And we learn that from fire. Fire goes up. Space station now offers us the ability to dissect deeper down into what the processes are in combustion that literally turn the wheels of our society by looking at it in an environment free from gravity, free from the gravitational-driven convection. And this allows us to look at things and figure out what's going on at a level that you could never see without taking it to space. And one experiment that I worked on space station, this last mission, was looking at solid air combustion and looking at it under lower convection, lower differential velocities between the air and the fuel that was being burned. than what is possible on Earth because of the convection. And what we found is that fades are more flammable than what we thought. That here on Earth, if you lower the convection to a certain point, the flame goes out. But in microgravity environment, we found that the combustion will continue at a state of lower convection than what we can actually go to here on Earth. And what the effect of that will be in terms of turning our wheels in our civilization, I don't know. But it's one small little step, incremental step in learning more about how this combustion process works.
Well, Senator, I'll just add that, you know, when we look at it, again, is trying to develop new pathways and develop new kind of markets, if you will, for certain things, we kind of look at it in I would say almost 4 areas. We talked about life science, and in life science, I think there's just a vast number of things that we can do in life science. We talked about muscle wasting, osteoporosis, you know, tissue generation, diagnostics, I think are really going to bloom in that area. Then we move over into material science. I think there's some very unique things that we'll see in the future in the areas of material science. Nano alignments, crystallization, different things that we can do by taking that gravity vector out. And then we move over into physical science and some others. But one thing that sometimes gets forgotten, and I look at it almost as a kind of a satellite guy, you know, we've constructed basically the largest, most powerful spacecraft up there ever imagined. So with that sitting up there, we can do some really amazing things in Earth observation. We can put new instruments up there immediately almost, and we're working on some of those now with companies. This is a vehicle that passes all of land mass every few days, and it's a great platform to do Earth observation. So, you know, there's a plethora of things that are really there, and I think it's for us to kind of compartmentalize them, put them out, and then get out to those industries that can really utilize them.
Senator Rubio, I had last Saturday 2-hour interview on a Saturday morning where I got a lot of phone calls that I had to answer that were exactly related to the question that you were just asking. Why are we spending so much money for that? And as Don just did, I think there is a lot of justification. Living in a world without gravity allows us to look into processes that help us to understand how life is functioning, a lot of physical processes and so forth, and that in turn creates certainly tangible benefits for society. However, and that I would like to add here, if we only look at those direct tangible benefits, I think we leave out an important aspect, and that is the fact that gaining knowledge, gaining insight into the surrounding is a benefit by itself, even if it is not immediately connected to, let's say, utilization here on ground. The aspect of exploration which Don described is one of these examples. If we fascinate our young people to get engaged in these STEM topics, I think that is also a benefit, which is maybe not directly tangible as maybe creating new materials or new drugs or vaccines that help us to fight diseases. But I think we always need to have the view on this overall benefit, the tangible and not the tangible ones. And last not least, I think the cooperation, the international cooperation, as I also stated before, is an important aspect of spaceflight. Working together in space is a very valuable asset. Thank you.
You know, just to add quickly, any physical phenomena that we have that has a little g in it, the gravity vector, when you take it to space and you remove that gravity, you get a different insight into that physical phenomena. And then that allows researchers and companies to potentially exploit that benefit like we've been discussing here in new ways we can't imagine. But it's tough to predict exactly where those breakthroughs are and exactly how they're going to pay back. But if they start, you could potentially start a whole new industry that never existed before. The other thing it does, I think, to Thomas's point, the intangible benefits, one thing is the creativity aspect. If you look at these student experiments that are flying up on the Japanese vehicle, the one student's experiment was to take a jumping spider and fly it into space. And this spider knows how to jump from one spot to another based on the gravity that affects the spider. So he knows exactly how to jump on his prey. What will happen in zero gravity, where he no longer has that gravity? Will this spider now learn and adapt to jump in a different direction as the humans do after a while? When they first get on space, they see these guys bump around, but then after a couple days, they're homed in on the zero-G phenomena, and they can float pretty effortlessly. Will this spider do that? But what was interesting is this student, you know, in his own creativity, he imagined what this would be like, and he thought about a physical phenomena, a physical insect, and said, well, how will that perform? And that creativity and that ingenuity and that excitement in the student it's just an amazing thing going forward. So how do you quantify that as being worthwhile?
What did the spider do? You know?
We don't know.
Oh, okay.
We'll spider news this fall when you actually get, Sunita will do the experiment. So, but that's the point. Is it's this inquisitive nature that really brings out the best in us and can really compel a nation to be exceptional.
Let us know about the spider when that happens. Now I'm dying to know. Thank you. That's great answers.
Senator Bozeman.
Thank you, Mr. Chairman. Mr. Gerstenmaier, one of the things that comes up a little bit, you know, we've lost American access to the space station using our, you know, space shuttle orbiters. I guess the question is, have we lost a significant barter-able asset that perhaps will diminish the amount of research that we'll be able to accomplish in the next 8 or 10 years? And from where we stand today, will our research be increasing? Our capacity, will it be increasing or decreasing as time goes by?
I think, as we've discussed earlier, from a cargo standpoint, we have a pretty good ability to get cargo to space station. You know, we have the HTV, the Japanese cargo vehicle, which is on its way to station. We have the ATV, which is from the European Space Agency, currently attached. We saw the SpaceX demonstration this year. They're going to schedule to fly again, possibly this fall in the October timeframe. Then Orbital is working on their cargo vehicle. Its demonstration flight should be probably by the end of this year, probably in the December timeframe. So we see we have a pretty robust with multiple vehicles that can carry cargo to station. That's important from a researcher to make sure that their research experiments get to space and get to space station. On the crew side, we have the Soyuz vehicle. We would like to get a redundant capability for that as soon as we can. That's the basis of our U.S. commercial crew transportation activity. We need to bring that online as soon as we can to have a redundant way of getting crew to space. I'm not concerned about the Russians' ability to do that. It's just our environment is very tough. You know, when we had the Columbia tragedy, the Soyuz was able to back up our transportation and was able to keep this continuous crude string that Senator Nelson talked about possible on board space station. So we were able to use that Soyuz vehicle during that time. Right now, we're essentially single string with one way to get crew to orbit, the Russian Soyuz. We would like to get our U.S. crew transportation system online as soon as we can, and we're working that as fast as we can, hopefully by 2015, 2016 time.
Very good. Thank you. Let me ask you guys, and again, whoever would like to comment, but as as a scientist and then just as a citizen, we've talked about the spider, we've talked about bone loss. I'm an optometrist, an eye doctor, and interested. I know there's been some visual, things that have gone on, but all of this research is going on up there and down here. I guess my question would be, what excites you the most, about specific areas that we're doing that you see the most potential in the future? What, if you had to pick a thing, what would it be?
I think one of the most exciting parts of going into a frontier are the pages of the book that don't have any writing on them yet, because you don't even know enough to know, should this be the exciting part? Should this be the significant part? And certainly you bring up the idea of these eye maladies where about 20% of the people living for long duration time on space station come back with these wrinkles on your retina. And there's a name, I think they call them chordal folds, these technical names. You know how engineers and scientists, they like to talk tech. But what they really are wrinkles on your retina. And depending on where they go, they can impact your vision. And we currently haven't a clue as to why they form. There are certain mechanisms for these wrinkles forming with people on the ground that have to do with elevated intracranial pressure. Again, another term for just saying the pressure in your brain. And we've just learned that these wrinkles can form on station crew members that have low to normal intracranial pressure. So thoughts on why these things form, we haven't a clue now. And another thing that makes this really fascinating is that they're predominantly in the right eye. So why is it just the right eye? Sometimes the left eye, but mostly the right eye. And these it's like a Sherlock Holmes story. These are little nuggets. These are little clues scattered about which tell us something about the human physiology. And again, the pages of this particular chapter have not even been written because we're currently in the process of writing them. The answers are clearly not in the back of the book. And when you go into a frontier, it doesn't get any better than this.
Mr. Royston?
Yes, Senator, I'd add to that. You know, one of our challenges is, and I think all of us in this room, is it's time, right? So we're looking at how we can get success as fast as possible. So one, it continues to show everybody that we need to keep this great outpost going. We need to continue the research. But for us and for my organization, one of the things we try to kind of bubble up to the top are those things that we think can have the earliest impacts. And we mentioned osteoporosis, and one of the things there is it's a good example of a known. Like we know there is bone loss in space. So in order to test osteoporotic drugs, you know, you need bone loss. And typically to get that, you have to test older patients that have other problems, have other things. Where if we're able to go into space, and I have an animal model there that is still in good health, but their bone loss goes down by 80%, that is an unbelievable test bed to be able to look at drugs and rapidly do either first fail scenarios or be able to determine what is going to work and what isn't. You know, as we talked about with either virulence or some of the other things, I think it's taking the knowns that we have, protein crystal growth, another one. We know that we can grow better proteins. We can do better crystallization because we've taken the vector out, that gravity vector, as Bill mentioned. But our goal is to really look at the knowns that we have up there in parallel with the unknowns. So we're trying to use what we know is current capability and things that are going to work with the fundamental science of why is it happening and what's it going. So from our perspective, it's a balancing act. We want to get moving on the things we know will make a good research test bed and development test bed, but also don't forget the fundamental science and the whys that it's happening.
Yeah, I think it really is important in the sense that you know, one of the things that you all have to do a good job as components of the agency is being able to relate, you know, what the positive things that are going on. And certainly we as members, you know, that are very supportive, the committee, have to do a good job of being able to relate to the public, you know, the fact that we are spending a lot of money, but this is the, you know, these are the very positive side effects that we're getting as a result of that. So thank you, Mr. Chair.
Mr. Chairman,
Senator
could I ask
Hutchinson, of course.
one quick question, because I've got to go, but I wanted to ask Mr. Gerstenmaier a two-pronged question. Number one, is there the possibility of extending the life safely of the space station beyond 2020? And if so, is it being considered? And second part of the question is, I'm fascinated by, this is a NASA picture on the observation issues that have been mentioned by several of our astronauts and researchers, and the importance of being able to see the Earth for river plumes, for flood depth, for earthquakes that or rather volcanoes that we don't feel yet, but you can see it from space, managing fisheries, oil spills, all those things. Can we put an orbiting satellite up with cameras that could do what the space station does, or are we in need of having another capability to do these observations?
I'll try to do both of these, and these guys can fill in a little bit. The first one, beyond 2020, we're looking technically to make sure that there's not any problems with extending space stations. So we're looking at, physical systems, seals, rotary joints, those kind of things, major components. What is the life limiting factor for space station? And we're doing that with our partners, taking a look at that. And we think we can, from a physical standpoint, station can be operable probably to 2028. We're still looking at structural life and other things. So we've done those investigations. I think it's important to us at this point to really focus on, as these guys have discussed earlier, of utilizing station and showing some benefit and return back. And if we can do that in the next couple of years, then I think the discussion about do we continue beyond 2020 becomes a little bit of an easier discussion. So at this kind of juncture of where we're transitioning from assembly to research, I think we need to get a little bit more of this research under our belts and to make the systems proven a little bit, that we can then sell those to our governments and folks to move forward to extend station. To the other question about Earth observation, I think station is a tremendous platform to do technology development. So if you have potentially a new sensor that is maybe not mature enough to actually put on a dedicated satellite, you could fly it very easily to station, mount it on station, get some quick results from it, and determine that, hey, this is really a good device to go use. And then after you determine that, then you could go put it on a dedicated satellite. We've done that with a couple. We have the iServe, which is essentially a telescope that will be set in the window observation facility. It's on HTV. It will look for disaster areas. It's part of the severe network where you can call up for a disaster. You can get location information. There's also I think a HICO-RAIDS experiment, which may have been the pictures you were showing to me there. Yeah, that's a hyperspectral spectrometer that was developed by the Naval Research Laboratory. That was a very quick demonstration to see what could be done on board space station with a quick device to get up and see what kind of information it could get out of it. It's actually operated for much longer than they anticipated, but it's a good test bed for those quick kind of tests to make sure that the equipment or the device you want to fly is really the right device to fly.
Thank you very much.
If I could add a couple of words. Oftentimes, it takes a human being in the loop to figure out what it is you really want to measure in the first place. And for example, you could put a satellite platform in orbit, and you know that you shouldn't look at the direct reflection of the sun off the ocean. That's called sun glint, because it could burn out your detector. Now, you put an astronaut on orbit, and sometimes they don't have the kind of common sense that you would think they should have. And we'll go ahead and look at the sun glint off the ocean because, wow, it's neat. And then all of a sudden you can see some structure off the surface of the ocean because of the way the lighting is coming directly from the sun. You can see things that nobody knew was there before because, of course, you don't take a detector on a satellite and let it look at a direct reflection from the sun. And once you make that discovery, then you could optimize a satellite platform for making that observation, and it could collect more data, possibly better data, than what the human being could have made in the first place. But it takes a human being somewhere in the loop to realize that you can look outside of where your initial design was made by people on the ground who've never been in space.
So important. It's so important because we do have people who say, oh, we can do all of this so much more efficiently with no people and just machines. But that's one very good testimony.
One thing to say about that, in space, there's no issue with machines, robots, and human beings working together. We work together hand and end effector in space. No issues. Where I find the conflict really occurs is here on the Earth. So in space, astronauts love robots because it allows us.
Square miles in Washington, D.C.
Yeah.
Thank you very much.
Senator, if
Senator.
I may add just a short comment also from a European point of view. We have launched an announcement of opportunity exactly in this regime last year, asking in the Earth observation community if there is indeed some interest to use ISS as a platform for Earth observation. And we received indeed a lot of replies, more than 80, if I remember correctly, and all very valuable replies, which were in support of using satellites as the prime platforms for Earth observation. And in fact, we have on the Columbus module, we have a sensor installed, a sensor that receives the identification signals from ships. And that is the classical application where you design the sensor, optimize it, and then bring it in future on satellites in an optimized way. And I think that is a good example how indeed the International Space Station, in addition to the examples that Bill and Don just gave, can be used in the area of Earth observation.
Thank you very much. Thank you, Mr. Chairman.
As you have to leave, Senator Hutchinson, I'm going to follow up asking about some things on cancer that you raised, and we'll get that information to you. Years ago, in the very beginning of the protein crystal growth, which cases Mr. Royston is now directing a number of those experiments. Originally, and when I participated in this experiment, it was actually proposed by the Comprehensive Cancer Center at the University of Alabama at Birmingham, was the sponsor of the experiment. And that over the years has morphed into the Protein Crystallography Center. And I would be curious from that very first experiment, of which we had some dramatic results. You take away the influence of gravity in growing protein crystals. They grew much larger and, at first blush, much more pure. The idea by the Cancer Center at UAB was, well, if you can then, back on Earth, determine the molecular structure of the protein, you could manipulate it to then do what you wanted with regard to cancer research. Now, this protein crystallography has been going on for years, and you're directing some of it right now, Mr. Royston. What's happened since January of 1986 on this?
And Senator, by no means am I an expert in this area, so I'll do my best to convey from the science team. And some of the people that flew with you and worked with you have still been involved. I think it's an area, if we had more biotech representation here, we'd hear that it is still an ongoing methodology by which a lot of drugs are looked at. Again, I think in the past, if we looked at the work there, it was somewhat sporadic. There was different types of equipment that was being looked at, being used. The Japanese have continued over the years to continue that research. What our goal is, and we've just put a solicitation out, is to really look at the different methods, look at the different hardware that can be used. NASA had a project that was going on, and we're partnering with to be able to, I don't want to say once and for all, but really look at this objectively, to be able to look at different ways to crystallize proteins, and then the methods by which we can look at them eventually on orbit, but also bring them back down in a way that we can get them into the right equipment areas or the right labs that can then, look at them and use them for what they're for. But I think, we've heard it clearly talking to large pharma, biotech companies. They're very interested in this. I think finally now that we have station, everything's built, we have a solid platform up there, good transportation capability back and forth. I think we'll see protein crystallization as one of the areas that will grow on orbit, no doubt.
Mr. Gerstenmaier, we worry about space debris, and from time to time have to worry about lifting the orbit of the station in order to avoid space debris. Tell us about that.
We have some shielding on the outside of the station that protects us from fairly small particles. And then there the large objects that we can track. We can determine that they may come close to the space station. We have a box that when we determine they'll come inside that box, we actually can do a maneuver space station to avoid a collision with those larger objects. And then there's another class in between that we really can't track yet, and they're actually larger than our shields, and we're at risk from those objects. We protected the station as best we could. It has the best protection system of any spacecraft we've flown on the outside. We're continuing to improve that. We made changes to both the Soyuz and the Progress vehicle. There'll be a Russian EVA in August to actually add some more shielding to the Russian segment, which will help with debris protection. We also put on board recently software. It used to take us about 3 days to get ready to do a debris avoidance maneuver. That software now is resident on board, and we should be able to do a maneuver much quicker. We're working with our Russian colleagues to actually get the details of how we could do that. So therefore, we could get identified from our tracking assets that there's an object that's going to come very close to station, and we should be able to maneuver in a very short period of time. So we're actively trying to improve the debris protection on station, both from a physical be able to move it standpoint and also improve the shielding on board station.
And I can't help but point out that debris is getting to be a problem in space, and the Chinese really added to the debris when they did their ASAT test. It added tens of thousands of particles at sufficiently high altitude that it's going to take a long time for gravity to pull those items back to Earth. And of course, that's what we and the other spacefaring nations have to worry about. And we try to track these, as Mr. Gerstenmaier said. Mr. Royston, let me ask you, what is CASIS doing to reduce the time it takes to identify and fund research opportunities and get those experiments up to the station?
That's a great question, Senator. As you know, and I think everybody in this room, businesses and the marketplace moves at the speed of light today. So if we go to them and say that, well, in 4 years from now, we think we can get you on orbit and we might be able to do some good stuff, it's not going to work. So one thing, I definitely want to acknowledge the effort that's been on Bill's side, on the NASA side, and the payloads office to transition from their construction phase and now into their operational phase. And our organization works with the payloads office on a day-to-day basis of how we can streamline those efficiency or get more efficiency, streamline the processes and procedures by which to do that. And then the other thing is CASIS. What we want to be able to go out there into industry and talk with potential customers is the fact that we handle all that for you, that we can be the organization by which allows you to think of the lab as just another lab. It's a lab like going from here in Washington down to Raleigh to do some experiments. You don't have to worry about rockets and all kinds of different paperwork and science advisory panels and everything else. We're there to do that for you. And I think we're making real progress in that. And I think that's really our key, again, to attracting some of the big market that we want to bring into the National Lab, is to show them that it isn't painful to get up there. It might be 300 miles away and it might be vertical, but it's not a big deal. It's a great laboratory. There's great opportunity, and we'll hold your hand and get you there painlessly.
Since we were talking about bone density loss, why don't you tell us about you're getting ready to fly a bone density scanner? And how does that play into the future osteoporosis research?
Well, we're not quite ready to fly it yet. We're doing a study right now with what are the best designs to be able to put a small bone scanner up there. So if we look at osteoporosis research, for instance, and we have an animal model that we're going to look at and be able to experiment with, one of our concerns, and I think we know it as far as transportation, and we're coming online with other options, is down mass. How can we get things back to Earth? And I think what the real focus in the short term needs to be is how we can do things on orbit and get the data that we need. That's a perfect example of now we have a small bone scanner up there, so we're watching the effects of the osteoporosis drugs on a day-to-day basis without being able to bring specimens back or being able to do that. And I think that's really key, not only as a bone scanner, but other equipment, whether it's the crystallography, Senator, as you mentioned, that we could do, you know, some determination or some review of the data or the crystals on orbit without waiting the time it takes to get them back down to Earth.
And Senator, I'd like to add that it's important to be able to collect more data points, particularly on human physiology, than pre-flight and post-flight, because there's a lot that happens in between and we have no data. And we're working on improving that. This bone scanner would allow us, you know, one more ways to poke and pummel astronauts on orbit to extract more nuggets of information from their physiology. And we're also working on getting advanced eye diagnostics on orbit too, again, to try to crack this problem of what's happening, what's causing the wrinkles in the eyes, when do they form? Do they form right away, or do they form towards the end of your mission? We don't know. And the only way we're going to find out the history of what happens when you get on orbit is to have these advanced diagnostic techniques that have been packaged from big laboratories and big centers on Earth, somehow shrunk down, somehow that can work in the confines of this orbital frontier. And then we can use these instruments to collect data from the astronauts on orbit. And one side benefit to this is every time we get an advanced piece of equipment, medical diagnostics, that we can use on space station, there shows up numerous places on Earth where this same technology can be applied to remote places that will help diagnose and correct ailments for people that never leave the planet.
You know, we've come a long way. Mr. Gerstenmaier, remember when we flew John Glenn 50 years ago, we did not know what was going to happen to the human eyeball. And it's been rather extraordinary, our ability to experience space. Final question for Dr. Pettit and Mr. Ryder. What do you think we can do to raise the awareness of this unique structure that is out there that the public does not have much awareness of?
One way is through education of our students, because the students are the future of this country, and they have the wherewithal to take us to the next phase, and we don't want them to forget about what it means to fly in space and do this exploration. And when I talk to students, I like to ask, how many of you would like to do my job? And you'd be amazed at how many want to do this. And I think you could say that there are more students that want to become an astronaut and fly in space than want to become president of the United States. And I think that's a good thing. And because we need them, we need the students in science, in engineering, in technology, and they need to have a strong foundation of math in order to work in those fields. And what would break my heart would be to talk to students and say we no longer can fly in space. We don't do that anymore. And that would break my heart. And we need to make sure that we can talk to the next generation and wind them up and point them in the right direction and let them carry the fire.
And I can pretty well tell you we will. Mr. Ryder?
Thank you, Senator. I can only support what Don has just mentioned. I think that these occasions where we directly tie in pupils from all over the world in experiments on board the space station really shows a remarkable effect. And Bill gave some experiments of the spider that is now on orbit, becoming an astro spider, and Don gave some experiments. André Kuipers, who was in orbit together with Don, he had some dedicated school experiments where there was a direct link, a live link to the station, and that was then disseminated in the schools, not only in the Netherlands, but I think across the world. And there are beautiful examples. I just had, beginning of the year, the opportunity to attend an event which was dedicated to an US experiment, Spheres it is called, where you can develop software for little satellites that are flying with carbon dioxide cartridges, and you can develop guidance, navigation, control algorithms for university students, and that found a great interest all across the world. So I think here also there is a fantastic opportunity to work together, and I think also in bringing these experiences into school books can steer the interest of our young generation in space, in exploration, and steer this, what is, I believe, in our genes, to be curious, to see what is beyond the horizon. Thank you.
Thank you. Senator Bozeman. Gentlemen, thank you. A most informative session. Thank you, and the meeting is adjourned.